We are going to continue looking at trig, but we are going to now relate it to a grid. So a Cartesian grid talking about our x and y values. So first of all, taking a look at angles in standard position. So when we're talking about a grid, we are talking about points on a terminal arm, creating an angle. So we're talking about our angle, theta, in between the x-axis, the positive side of the x-axis, and our terminal arm. And our terminal arm just encloses our angle. So creating a right angle triangle between the point itself and the x-axis. We can take a look at those values. Well, this right angle triangle then has measures of x on the bottom, y on the side, which are just our x and y values of the point, and r is the radius of a circle. If we were to create a circle around using that point at various terminal arms, we could create a circle. So radius is the distance between the center of our circle and our terminal point. So using that, okay, we have our middle value of 0, 0, which would be the center of our circle as well. And as I mentioned, the initial arm of our angle is the positive side of the x-axis. Okay, so we're always going to create our triangles with the x-axis. Now, as I also mentioned, r in this case is the distance from the vertex or the starting point of 0, 0 to the point, which we have on our graph of x and y. Now, we can still use our sine, cos, and tan ratios using the information from this triangle. The one thing I want to point out is if we have a positive angle, that means that we have a counterclockwise rotation. Okay, so we're heading this way if we have a positive angle. A negative angle simply means that we're going the opposite way. We are going clockwise to create our angle. So positive would go this way, negative would go that way. So looking at sine of our angle in here, we can come up with our ratios using our x and y values as well as our radius from our right angle triangle that we've drawn here. So sine theta would be our y value of our point over the radius, right? Opposite over hypotenuse. Cos theta would be x over the radius, the x value adjacent over hypotenuse, and tangent would be y over x. So we can use points on a terminal arm to determine our sine, cos, and tan ratios, and then in turn to be able to figure out what the angle is between our initial arm and our terminal arm. We also want to keep in mind that Pythagorean theorem, this is still creating a right angle triangle, that x squared plus y squared is equal to r squared. And that's going to help us determine our three ratios if we only have the point, or if we have the x value of the point and the radius. So to draw in standard position, again, we are starting with our initial arm of the positive side of our x-axis, and we are drawing our angle, our terminal arm, to create that 60-degree angle in between those. If we are drawing a 135-degree angle, we know that we're going to go to the y-axis, creating 90, and we're going to go another 45 past that to create our 135. And we know that the 45 is going to cut our second quadrant in half, and we've got our angle of 135 degrees. If we are going to create a negative 270-degree angle, okay, we're still going from our positive side of our x-axis, but we're going counterclockwise. So we're going to go this way. We get to 90 this way, 180 here, and we're going to go to 270, negative 27 going clockwise. So our terminal arm is going to be on the y-axis going negative 270. Okay, so positive angles rotating counterclockwise from the x-axis, negative angles going clockwise from the x-axis. Now, we can talk about coterminal angles, and those are where our terminal arm is at the same position. So we could have, if we have a 30-degree angle, like we're told we have here in example number 2, that means that we have our terminal arm creating a 30-degree angle in here. Well, if it's coterminal, that means that we could go one more full rotation back to the same spot. So we can find a coterminal angle by simply adding one full rotation. So an angle of 390 degrees is in the same position as the 30-degree angle. We can add 2 rotations of 360 or 720, and an angle of 750 degrees would have the same terminal arm. We can also go backwards. So we can take away a full rotation. So an angle of negative 330 degrees would also end up in the same spot. And again, we could take 2 full rotations away from that, and an angle of negative 690 degrees would also have the same terminal angle. If we're looking at part B, we have a terminal angle creating an angle of negative 45 degrees. And again, we can find coterminal by adding 360, subtracting 360. So starting at negative 45, if we add a full rotation, an angle of 315 degrees from the positive would have the same terminal angle. And again, if we add 2 full rotations, that means we would have an angle of 675 degrees, falling at the same spot. And subtracting, we would have negative 405, and 2 full rotations, taking away 720 means we would have negative 765 as, did that one wrong. We would have negative 360, no, negative 765 is correct. Okay, so we can find coterminal arms just by simply adding a full rotation or taking away a full rotation. Example number 3, we have a point at 3 and 4. So that's the first thing we're going to do. We're going to estimate our point at 3 and 4 on our grid, and we are going to draw our terminal arm from there. Okay, so again, we're going to take a look at theta in between our initial arm and our terminal arm. And we want to find the exact values of sine theta, cos theta, and tan theta. So we're going to use the fact again that we can create a right angle triangle. We have a measure of 3 here, 4 here, and we can determine our radius. So we know that first thing we want to do is calculate our radius, and we can do that by using x squared plus y squared equals r squared. So subbing in 3 squared plus 4 squared equals r squared, 9 plus 16, and we get 25. Remember that when we square root a number, we have to take into account that it could be the positive or negative. And we know a radius can only be positive, so we're now going to eliminate the negative value. Okay, we know a radius has to be greater than 0 because it's a measure of distance. So r is equal to positive 5. But we always have to keep that in mind. And this is, I know your math teachers have probably preached this for the last few years, that you have to keep that in mind. It is especially important when we're calculating x or y here, because we know that we have positive x values, negative x values, positive y values, negative y values on your grid, and it could be in 2 different positions. So we really want to keep that in mind. We have to account for both answers when square rooting a number. So now that we have all 3 measures, we are going to set up our ratios. Sine theta is equal to y over r. So our y value is 4, our radius is 5. So sine theta is equal to 4 over 5. Cos theta is equal to x over our radius. And if we forget that, we can just look at our triangle over here. And x is 3, radius is 5. So our cosine ratio is 3/5. And our tangent is equal to y over x, which means that is equal to 4 over 3. And those are our exact values. We weren't asked to find out what the angle is. We were just asked to find our sine, cos, and tan ratios. If we have -6 and 2, so -6 and 2 occurs somewhere over here. And again, we're going to create our terminal arm. And what we're looking for is theta, okay? Or what we're working with is the angle in here. Now, we are still going to create our right angle triangle over here with the x-axis though, because we want to work with our x and y values, and we want to be able to determine our radius value over here. So our x is -6, our y value is 2, so we're still going to use x squared plus y squared equals r squared, and we're going to sub in -6 squared plus 2 squared equals r squared. So we've got 36 plus 4, so r squared equals 40, the square root of 40. Now, we're going to leave this as exact because we want our sine, cos, and tan in exact values. We don't want to round this. So we're going to state radius as the positive or negative of the root of 40. Again, r is greater than 0, so our radius is going to be the square root of 40. And now again, we're going to simplify this though. Remember, we're going to change this. We can take the factor of 4 out, square root it, becomes 2 root 10. And now we can state our ratios. So sine theta is equal to, and if we're not sure, we're still using this angle in here. We know that supplementary angles have the same sine ratio. So we have 2 over 2 root 10, y over radius, and we can simplify that to 1 over root 10. Cos theta is equal to negative 6 over 2 root 10. Simplifying, we get negative 3 over root 10. And tan theta is equal to 2 over negative 6, which simplifies to negative 3. And again, we have those exact values for our ratios. Okay, so this is just a matter of drawing our angles on our grid and using the information that we're given to find our ratios, which in the end will also help us figure out our angles. Okay, so you have some practice on your worksheet, and have a great day.